schedules have to listen to my recordings, which I'm okay with because they told me ahead of time. Can anybody, when you are, I want everybody to think about when you're tightening a wire on a screw. This sounds stupid, but I really have to just address this because it was in your reading at some point, but I know a ton of people are missing this one on previous conversations. When you tighten a wire on a screw, or when you tighten a screw, are you tightening it clockwise or counterclockwise? When you tighten a screw, clockwise or counterclockwise?
Clockwise. Clockwise.
It's always clockwise. Okay? So when you loop a wire around the screw and you're tightening it down, does the loop of the wire go, you know, the hook on the end of the wire, does it go counterclockwise or clockwise?
Counterclockwise. Should go clockwise as well.
It should always go in the same direction that you're tightening your screw. So the loop on the end of the wire, or the hook, always goes in the same direction you're tightening the screw. The reason why we do that is because then the screw doesn't push the wire out from under it. Okay, so again, if you have a hook on a wire when you're tightening it under a screw, it goes clockwise, the same direction that the screw tightens. Okay, and if you can't remember counterclockwise and clockwise, righty-tighty, lefty-loosey. Okay, the lack of better terms. The student a number of years ago told me that one. Okay, so again, clockwise, the hook on the end of the wire goes the same direction that you tighten a screw. Okay, switches on an oil furnace, and again, this was in your NORA reading at some point, which, by the way, the NORA reading are PDF documents that were along with the homework assignments on the modules. The NORA chapters. It did go over this in one of them. What's the name of the switch at the top of the stairs or outside the room where the furnace is at? There's a specific name for that switch.
Safety switch or emergency switch?
Let's go with emergency switch. What is the name for the switch that's mounted on the side or within an arm's distance of the furnace or boiler?
Service switch?
Service switch. Okay, please don't get the two of them confused. Okay, emergency switch is actually labeled as such most often on the red cover to the plate. By the way, that's the one the kids most often turn off and cause the service calls. Okay, that's at the top of the stairs or outside the boiler room or furnace room by code. The service switch is specifically there so that the technician servicing the equipment can turn it on and or off. Okay. Anybody remember what I said the appropriate spark, we talked about this when we talked about igniters. When we talked about the igniters, does anybody remember what the gap between the two prongs of the igniter should be?
Like 1/8 of an inch?
1/8 of an inch, that's perfect. Now, is it possible if the spark gap is wider or if the transformer is a little bit weak, could the flow of air blowing down the tube actually blow that spark off the igniters and get it out of position?
Yep.
Yeah, a heavy airflow will blow that spark off the side, off the end of the igniters. That's why that 1/8 of an inch is so important. Okay, split phase motors. What's a split phase motor? Give me a definition of a split phase motor.
It has a start and run winding.
Has a start and run winding. Okay.
No capacitors.
Might not, well, I want to say might not have a capacitor, okay, because any motor with a start and run winding is really a split phase motor base with extra start components on it if it has capacitors and stuff. But a true split phase motor, you're right, does not have a capacitor or start components. How is the start winding taken out of the circuit?
Centrifugal or potential relay.
Most often in the oil side of things, the centrifugal switch. Once you start getting into the refrigeration and the higher stuff, it will be a relay on the outside. But most often we're dealing with a centrifugal switch. You're right on that. Okay. When we have split phase motors, we've talked about capacitors pushing the phase, or that sine wave that I showed you, out of phase a little bit. How many degrees out of phase is that? Remember, we have 360 degrees in a full circuit. How many degrees out of phase is that current?
120?
No, that's my voltage. So it's most likely going to be a number between 1 and 90. How many degrees out of phase would that be most often?
60?
Okay. It is, and everybody probably want to jot this down. It's sort of important. Okay. The start winding is 10 degrees out of phase with the run winding in a split phase motor. When we start adding capacitors, it gets more than that. But in a true split phase motor, and this was in some of the reading material, okay, and I think it was on one of my PowerPoints, but the split phase motor is 10 degrees out of phase with the run winding. Okay, so when we have a sine wave, we have that wave pattern that's going into the run winding that's coming from true run, from our line. The start winding is 10 degrees out of phase with the run winding. Okay. I spent time last night and this morning going through your exam on Friday. I pulled out a couple questions that I just didn't feel were fair. The test has 98 questions on it, for those who wanted to know. The things that I just went over, I actually went back and looked at the last class that took oil, and I looked at some of the answers, and the things that I just went over, believe it or not, were the most often wrong answered questions on the exam. So that's why I just took the time to go over that, because I know people sometimes don't pick up on some important stuff in the reading that's frequent, and I just wanted to make sure that we covered some of that. The wires on the screws, the direction that the screw turns when you're wiring something, believe it or not, was the #1 misanswered question on the exam. So, any questions on anything I just touched on?
No, sir.
No, sir.
Okay. Couple other things that don't affect 90% of the people on this call, but I guess some people have some questions on it. If by chance you don't have one of your books, okay, other than the NORA book, because there's no NORA book, that's PDF documents that are in the modules, okay, if by chance you don't have your modern refrigeration book yet, click on school links, or if you're using the app, okay, click on student links, I think it's called, in the app. Find the ebook and app code orders, follow the directions through. You can get your book. Okay, NORA is not a book. Wherever I have a homework assignment that has a NORA reference to it, and I can't remember where the last one is. Okay, wherever there was a homework assignment that has a NORA reference to it, okay, the chapters for the NORA material is on the same module right under the homework assignment. Okay, again, the NORA manual is not a book on your bookshelf. You have to go to the modules by clicking modules on the course if you're using the app, and you have to find the homework assignment, and right under the homework assignment is the NORA manuals. Okay, that's the #1 most frequently asked questions in my email last night. The second most frequently asked question in my email last night is, why can't I get into the discussion boards of the day or the assignment of the day from prior days? because it was the assignment of the day. They're closed. Okay? You can't go back and do the entire course on the last 3 days of a course. That's not happening. So the assignment of the days, they're closed after that day is over. Homework is still open. Other assignments are still open. And if it's late, we lose points. Okay, I refer you back to the syllabus. So again, 90% of the people on this call that does not apply to. Okay, and I went over this all on the first day of the class. So moving on, because I'm really not entertaining questions on that. Okay, moving on. We want to talk about stack relays today. Okay, what did I say about stack relays when I briefly talked about them yesterday? Can anybody tell me anything important about stack relay versus CAD cell?
Stack relays are very rare nowadays.
They're much rarer. Why?
Because they take longer to, I forget what it was. I think take something out of the circuit.
Yeah, they take longer to trip. They take longer to sense the heat because it's in the stack. You're right. Okay, so again, we cover stack relays in this course very specifically because there are some still out there, and the licensing exams, the oil licensing exams, both in Connecticut and Massachusetts, still talk about stack relays. Don't understand why they're going away, but they still talk about stack relay. Okay? Basically, the stack relay is an older type of primary control. It's going to trip if no flame is detected on a call for heat. The stack relay senses temperature, not light, and it specifically senses the temperature of the exhaust. Okay? There's a bimetal sensor that sits inside the furnace flue pipe. When the furnace heats up, okay, it heats the element. Now, as I go through this, I don't know if you saw on today's module, there is under additional resources. I'm sort of highlighting it right now. It's in blue on my screen. There's a PDF handout for stack relays. Okay, this presentation refers to the material on this PDF handout. Okay, so again, on today's module, which is labeled Stack Relays with today's date, okay, there's a PDF handout under additional resources that this PowerPoint does refer to. Okay, it's called PDF Stack Relay. Okay. So, as the elements start to move, it sequences the contacts. So when we go over to my stack relay picture, okay, sorry, older picture, it is what it is. We have this part of the stack relay is in the smoke pipe. This part of the stack relay is my controls and where all my wiring is. That's hanging outside the smoke pipe. Has a cover on it just because there's 120 volts in here as well as 24. Okay, so this has a bimetal element in it. As this heats up, it starts to push in to the relay. As that heats up, it starts to push a shaft into the relay. Okay, so that's what I'm talking about as it moves. Okay, so the first picture that we're going to talk about shows the relay de-energized. There's some very specific contacts I want you to take a look at, and I'll show it to you on the next slide. Okay, the cold contacts are mid-seated, and the hot contacts are open, and I'll explain this in a second here. Okay, from your handout, there is a diagram number 211-2A. It says it at the bottom of the handout. Okay, it's 2A. The stack relay is primary, is cold. Okay, what we're very specifically looking at is the hot and the cold contacts. Okay, these are the cold contacts, and these are the hot contacts. It's exactly what it says. The cold contacts are closed when the bimetal is in the cold position. And the hot contacts get closed when the bimetal heats up and is in the running position. In other words, there's hot air coming through the bimetal, through the stack, okay, which is the sense of flame. So when the relay is de-energized, okay, thermostat's not calling for heat, okay, we basically have, okay, cold contacts are closed, hot contacts are open. Now, if the thermostat is not calling for heat, and I take a voltage reading across W and B, what am I going to get on my voltmeter? Thermostat not calling for heat. I take a voltage reading across W and B. What am I getting on my voltmeter?
24.
24 volts. Okay. Given that, is my 2K relay energized or de-energized?
De-energized?
Yeah. Is my 1K relay energized or de-energized?
That should be energized.
Thermostat not calling for heat? I don't have a closed circuit here, right? There's
Right.
an open right here. Okay? So are these relay coils energized or de-energized?
They're all de-energized.
Everything's de-energized. Okay? Now, once the thermostat calls for heat, it energizes 1K and closes 1K1 and energizes the ignition sequence. It also energizes 2K, okay, and it will close the 2K relays, energizing the oil valve and the burner motor, and I'll show this to you on a picture. So again, now the thermostat is closed. It's providing current down through the thermostat. And it's coming down to B. We've now energized the 2K and the 1K relay. It has closed 1K1. It has closed 2K1. It has closed that. So we're now energizing our ignition transformer. We're energizing our burner motor. And we're energizing, if there is one, our oil valve. Does everybody see that?
Yes, sir.
Mm-hmm.
We've also energized, because our power is actually coming through here, we're coming through our cold contacts, and we're coming to our safety switch heater. This heater is going to start heating up. The minute we have a call for heat and everything else is energized, that heater starts heating up. Okay? Now, the burner is now energized as well. As the flame heats up the flue pipe, the bimetal in the stack relay starts to move as well. This will start to sequence the hot and the cold contacts. So now what's happening is my hot contacts are starting to move closer together. They're not touching yet, but you notice what happened to my cold contacts down here. Can everybody see this? What happened here? Is the safety heater still energized?
Negative.
Right, because it's starting to sense hot air in the furnace exhaust. That safety switch heater is no longer fully energized. Okay. Now, is my 1K relay still powered?
Yes, it is.
Because I still have a path through my right side of my cold contact back to my transformer. I still have a path. Okay? As the bar starts to move, the burner starts to move the cold contact and stops the safety switch heater from heating. That's what I just showed you. The cold contact has moved away from the SS heater circuit, and lockout will no longer happen. The safety switch stays closed because it's no longer getting heated up. Okay? Once the flame is established, the ignition transformer drops out. Why do I need to provide power to an ignition transformer if there's flame? I really don't need to. When the hot contacts close, the cold contacts are completely disengaged, de-energizing the 1K relay. And I'm going to show that to you now. So here, this system is running. My cold contacts are open. I no longer have a path through that 1K relay. Therefore, my ignition transformer no longer has power. My burner motor is the 2K relay, and it continues to run because it has a path of power through these hot contacts.
Yes, it does.
So my burner motor continues to run, and if I have an oil valve, it stays open. Questions?
No, sir.
Okay. Now, the next picture that I show you is going to show the control tripped out on a no flame condition. Okay. The heater got hot as the contacts never sequenced to take it out of the circuit. Okay. So here, we have our cold closed. Okay, thermostat may be providing power all the way through here. But because this is closed, but the safety switch opened. Okay, we've basically de-energized everything. This safety switch, is this a manual or an automatic reset? Manual or automatic?
Is that a automatic?
No, on all oil equipment, the safety switch, that's the button you actually have to push in to reset, the red button. That is always going to be manual. Okay, please be careful about that. Safety switch, manual reset. Okay. A lot of background noise from somebody. I hope you're not trying to ask me a question. Okay. Safety switch, manual reset. How many times should you reset it max?
3 times.
3 times. Okay, stack relay, if you look at it, it's actually a very simple device. The problem with the stack relay was very specifically that it didn't open fast enough. Okay? It doesn't time fast enough. It has to have a longer time delay, which means more unburned oil. Okay? Stack relay has a couple other very important things. The wiring terminals. Okay? Pin 1 gets my line voltage coming out of my high limit. Pin 2 isn't right next to pin 1. It either gets line 2 or neutral, depending on the size of this thing. Pin 4 is always my ignition transformer. And pin 3 always gets my oil burner and anything else that needs to run constantly while my burner's on. For example, the oil valve. Okay? These are always the same. It's a standard. They'll never get messed up. But you do got to remember that pin 1 and 2, believe it or not, are not next to each other most often. Okay? That's stack relays. Now, looking back at the diagram that I gave you, the handout, when you look at a side view of the stack relay, this portion is mounted in the flue. It has the bimetal element and the drive shaft in it. There's a mounting bracket. That's what screws to the side of the flue pipe. Okay, from here to here is basically the case that this thing is sitting in with all your electrical connections. Mounted where you can't really see it that well because we want to protect them are our contacts. They're all tied to the drive shaft, okay, by using what we call clutch fingers. It's just what they're named. There's 2 of them. Now, what I really important want to point out to you is that there's a reset lever on this drive shaft. When you get back into shop, okay, I've asked the shop instructors to show this to you, on campus. Occasionally, these get out of sequence, okay? After so many times or after so many false starts, heating and cooling, these drive shafts and these clutches get out of sequence. You can slowly pull this reset lever out. Okay, you pull it out, not hard, very slowly. Okay, don't need to do a lot, but you can actually reset this whole thing by pulling this out to the end and then slowly letting it go back in. And you can reset the entire clutch assembly on these things. Okay, and it needs to be done every once in a while. Okay, if you have random trips, if you have a situation where you know the controls are good but not restarting, before you replace the burner control, before you replace the whole control, try resetting the lever. Okay, 9 out of 10 times that will solve the problem. Okay, so that's important to know. The reset lever will reset the clutches, the drive clutch and the fingers. Pull it all the way out, slowly release it. 9 out of 10 times that will fix the problem with controls. Okay, there's another picture, a little bit of the arrangement of the hot and cold. I'm really not that awfully worried about them. You don't really need to know the internal workings. You'll never fix these things. You replace them. Okay, now this is actually pretty important. This is my furnace or boiler. Every system, every oil system, and we'll talk about this probably starting next week, has a draft regulator on the furnace exhaust, on the smoke pipe. The primary control, the stack relay, has to be at least 18 inches away from the draft regulator towards the furnace. Can't be within 18 inches of this, or it won't sense the heat properly from the burner. Okay, because this whole draft regulator is designed to allow air from the room into the exhaust. Okay, it will actually allow air in that's cooler than what this primary control wants to sense. So 18 inches is the minimum that this needs to be away from the draft regulator. Any questions on that?
No, sir.
Okay, sort of important on that one. And again, this just shows you how things are wired. Okay, some of them, they don't even use pin 4. If you want your burner motor, oil valve, and ignition to come on all at the same time, you just leave pin 4 empty. You put everything on pin 3. Okay, just a couple different wiring options here. Okay, there's a view of this thing with the cover off. They all look the same. Okay, it has the transformer right in it. Okay, there's some manual trip levers, there's safety switches, there are low voltage terminal boards over here. Okay, again, they're all pretty much the same. They've been around for many, many years and they've never changed. And then here's the diagrams I showed you in the PowerPoint. Okay, any questions on stack relays?
No, sir.
Okay, I have a suspicion we have a lot of people that might have questions and no one asked. Any questions on CAD cell primaries. What's the resistance of a CAD cell in the dark?
Can you repeat that?
What's the resistance of a CAD cell in the dark?
1,000.
Are we sure on the 1,000, or could that be a CAD cell in the light?
CAD cell in the light should be under 1,000.
Yeah, a CAD cell in the light is going to be under 1,000. What's a CAD cell in the dark?
Over.
10,000? Under 1,000.
It's going to be close to 100,000.
Oh, close to 100,000.
Okay? Going to be close to 100,000. Okay. Let's a little bit, I'm not going to go all the way through this. I'm not going to talk 100% about fuel pumps today. We're probably going to end this a little bit early today because I want to give you guys a chance to get caught up on some of your work and some of your reading. The NORA material is pretty important. But remember I told you there's only like 3 moving parts to an oil burner? What are those 3 moving parts? What are your 3 moving parts to an oil burner?
Blower motor, burner motor, fuel pump.
When you say blower motor, what specifically are you talking about?
The squirrel cage.
The squirrel cage that's inside the burner compartment, right?
Yeah.
Okay. Because blower motor could also be referred to as the part that moves the air around the actual furnace in the house. So just want to be sure we're talking about the same part. You have the squirrel cage inside the blower, inside the burner housing. You have the motor, and you have a fuel pump. That's our basic 3 moving parts on an oil burner. Okay, there's more in the furnace itself, but those are our 3 parts. Okay? So oil burners for residential as well as just about any other have pumps, okay? They're connected to the motor through a coupling, okay? Now the oil pump is not just a pumping device, okay? It's a pressure regulating device and it has a filter in it. More and more, the manufacturers of these devices are no longer calling them oil pumps. Believe it or not, they've come up with a longer name of it. It's called a fuel delivery unit. Okay, again, they want to stress that it's not just a device where we're pumping oil. It's the device where we're actually regulating the pressure of the fuel pumps as well as a couple other things. Okay, so we want to be careful. It's a pump that pumps the oil. It's a pressure regulating device, and it also filters any contaminants in the fuel. Okay, 3 points to a fuel pump. Okay, we have a couple different size pumps. Okay, we have a single stage pump. It has 1 gear. Okay, it's used on gravity fed systems, and I'll talk about that in a minute. Okay, it's not to exceed a 10-inch vacuum. It cannot pull. It doesn't have a lot of suction pressure. It cannot pull a lot of fuel from a long distance. Okay, single stage pump, 1 gear, used on a gravity fed system, not to exceed 10-inch vacuum. Okay, that's one type of pump. The other type of pump is what we call a 2-stage pump. It has 2 gears, and it's used where the tank is below the burner. Okay, it has 2 gears. It can actually lift. Okay, it is suitable for a 15-inch vacuum. In other words, it's a much stronger pulling pump. Gravity-fed systems means that the fuel tank is higher than the burner. Okay, the pressure of the fuel pushes down and will self-feed into the burner. Okay. The 2-stage pump is used where the tank is below the burner. Now let me ask you a question. if you have a fuel tank on one side of your basement, and that's a fuel tank, okay, there's a line that comes out of the fuel tank. It goes up to the basement ceiling. It comes across the ceiling and comes down to the burner. Okay, this is the burner here. If there's legs on the fuel tank that pulls this 18 inches off the ground, if my burner is 6 inches off the ground, can I use a single stage pump or do I need a two-stage pump?
Isn't that a two-stage?
Is the burner above or below the fuel tank?
Below, so you'd only need the single stage.
As long as there are no leaks, no air leaks, any place in the system, once I have the pump primed, okay, this is considered a gravity fed. It sort of acts like a siphon, okay? So a siphon can go up and come back down as long as there's no air leaks any place in the system. Now, if it's an extremely long run, let's say we're talking 40 feet, 50 feet of piping, then I may need to go to a two-stage pump. But as long as it's a shorter run, and as long as the oil burner is below the level of the outlet of the tank, and there's no air leaks, which there better not be any air leaks in an oil system anyways, okay, I'm fine on a single-stage pump. Okay, things like lift, that's how high the oil has to come up. Horizontal run, how far away the distance is from the burner to the tank. The number of fittings, the filter that's in the tank, all make a difference on how much vacuum I need. Okay, I could have an oil burner sitting next to the tank, but if I have 4 or 5 filters, a whole bunch of fittings, a whole bunch of couplings in this line, I could need the larger pump because all of this makes a difference. So in this example, this is assuming we have a nice clean run, maybe one filter here, and everything is clean. You can get away with a smaller pump. Okay, do I want to run a smaller pump when possible? Yes. Okay, you don't necessarily just have to run a larger pump because it's a sloppy install. Okay, a lot makes a difference depending on the way it is installed. Pump should be sized for a complete system. Okay, it's all based on vacuum, which is expressed in inches. Okay, there are some rules of thumb. We use 1 foot of vacuum for each foot, or 1 inch of vacuum for each foot of vertical lift. I use 1 inch of vacuum for each 10 feet of horizontal run. I use 1 inch of vacuum for every elbow. I use 1 inch of vacuum for every oil filter. Okay, and I use 2 to 4 inches of vacuum for every check valve. And we haven't talked about these things yet, but you find these in every single oil system. Okay, so this is very controllable. My vertical lift is very controllable. My horizontal run, that's how far it is away directly from the oil tank. Okay, that makes a difference. Can I always control that? Do I have any say in a lot of times how far away that burner is?
No, you don't. No.
Why?
Sometimes that's just how they're built.
Well, I'm more looking for it has a lot to do with where the chimney is in a lot of houses. Okay, you put the oil burners very close to a chimney, unless they're using a power venter that goes out the side wall of the house. Okay, what about the elbows? Do I have any control over this? Elbows. which is like 90-degree bends in the piping. Do I have any control over that?
Yes.
Yes, I have a lot of control over that. If I use gradual bend, so if I have to change direction and if I use a gradual bend rather than a sharp elbow, my oil will flow much nicer in the gradual bend. Okay, oil filter. Very close to what your car oil filter does. Okay, there's no mystery in here. It's very close to what your car oil filter does. It filters contaminants out of the oil. There's different types of oil filters. Okay, there's some single use. There's some disposable. There's some where you just replace the filter element inside. Okay. Check valves. Okay, check valves are used sometimes when we want to prevent oil from flowing backwards through a system. Okay, if there's for some reason, some oil systems occasionally might have a small leak someplace and it will constantly try to feed oil back to the tank, especially when it runs up along a ceiling or when the burner's above the tank. Check valves. There's another type of check valve you find in oil systems. Does anybody on the call know where that is? I think I have a couple people working in the oil industry. Do you know where those other check valves are? Okay, they're called anti-leak check valves or gravity check valves. Sometimes we put a check valve into an oil line. Okay, so I have my oil tank. I'm coming out of my oil tank at the bottom. Some areas require per code us to put a check valve in here. That this valve will only open and allow oil to flow when the oil burner pump, when the pump is calling for oil. In other words, if there's a vacuum on the line between the check valve and the pump, in other words, it's trying to suck oil, this check valve will open. If this line is cut or falls apart or is disconnected, this check valve will not open and it will keep the oil in the tank. These tanks can be between 250 and 500 gallons sometimes. You don't want 500 gallons of oil spilling out a leak if you can avoid it. So a lot of towns and municipalities require a check valve in that oil line to prevent us from having an oil leak that spreads oil all over the basement floors. Okay, so, but again, it eats up vacuum, okay, because that pump has to be able to pull this much vacuum along with everything else to open that check valve. That's why check valves are required. Can anybody tell me what a firematic valve is?
No, sir.
I thought it was in the reading I assigned. Okay, a firematic valve is a valve that's actually in the oil line. Okay, that closes if there's a fire. Okay, so the oil line comes out of the tank. My tank's like right here. Okay, the oil line coming out of the tank has a valve that's right as it comes out of the tank. There's another one on the burner side as well. But if there's a fire, okay, this valve actually melts and closes into the closed position. I'll go much more over this starting next week as we go into the mechanical side of things. But this valve closes, and there's a little, and the valve drops down. There's a solder plug that will actually melt and close off the oil line to prevent the oil from feeding the fire that's in the basement or in the room. And again, there's going to be one on the tank and there's one on the burner. Firematic valves. Again, because it's interrupting the flow of oil, it has a vacuum equivalent, which is roughly 3-inch. So can you see by looking at these equivalents how vacuum requirements for an oil burner can actually start adding up pretty fast? Okay, and if you don't have the correct size pump on this, you can actually go beyond your vacuum requirements very, very easily. Okay. Any questions on this?
No, sir.
Okay. There's some fuel pump limitations that you have to be aware of. Okay, and some of these are by design. Okay. There's a shaft seal. That's where the motor, where the shaft, you have your oil pump here. You have a shaft that comes out of the side of the oil pump. There's a seal around it. It cannot handle anything over 10 psi. In other words, if you have too much pressure on this. So if the oil tank is like up sitting on top of a building or way up over a basement, this shaft seal might not be able to handle the pressure sitting on this shaft if it's over 10 psi. Okay, so shaft seals will blow at 10 psi. When a shaft seal goes, you have oil all over the place. Okay, single stage units. Okay, that's the single stage fuel units, the fuel pumps. We don't like using them over 6 inches of vacuum. They can handle 10, but we don't use them over 6 inches of vacuum on a single pipe system. Don't worry about these two numbers right now. We'll talk about these in the next week or so. We don't use them over 20 inches of vacuum on a 2-pipe system. Basically, all this means is how many pipes are coming from the oil tank. Single pipe, we only have a single supply line. 2-pipe, we have a circuit that goes back to the tank, okay, and it has a return. We use these in different circumstances. We'll talk more about this. But again, single-stage units have limits. We don't want to go over these limits because it can cause us problems. Okay, fuel pumps have different parts in them. Okay, we have the old-style bellows pump, which basically, if you ever think about bellows, like on it's a open and close. It's sort of a spring-loaded cloth-type bellows pump. Okay, up and down motion. Okay, those are older style. I don't think you'll ever see them anymore. The newer style are full of gears. They're gear-driven. So if you pull the pump apart, you have a whole bunch of gears. Sometimes they fall out. Don't do it. Okay? The whole purpose of this, it provides the suction from the tank, and it provides the pressure for the burner. The oil itself provides the lubrication. So again, the pump provides the suction for the lift. That's to get the oil out of the tank and to the burner. The outlet of the pump provides the pressure for the burner. Okay? And the oil itself provides the lubrication through that pump. Now, what is the pressure for the burner? What's our oil pressure? What should it be? Anybody? Oil pressure, what should it be? How many psi? We've talked about this.
10.
I think it's 100.
It's 100. What are the newer pumps being set at? What are the newer systems being set at?
140.
140. Everything in oil is rated based on that 100 psi. If you have 140 psi, there's adjustments to the ratings you have to make. Okay? The oil pump contains a pressure regulating valve. Okay? It does the oil nozzle pressure, and it forces the pressurized oil to the nozzle. Your oil pump also contains a strainer. Okay? It prevents the sediment and contamination of the oil pump and the burner. Okay? The strainer is the final point of filtering before it gets to the nozzle. Now remember, I showed you on a nozzle that there's an extra filter on the nozzle just as a last ditch to prevent anything from getting into the nozzle itself, which will clog the nozzle. But that strainer screen that's on the oil pumps, for the majority of the oil pumps, needs to be changed. Needs to be changed out once a year. It needs to be checked. There's also a shaft seal that prevents the oil leakage. Okay? So again, my oil pump contains has the pump itself, which provides the pressures and the suction. It has a pressure regulating valve. It has a strainer screen and a shaft seal. So this is not just as simple a device as a pumping oil. That's sort of what I'm trying to get to. There's a lot more to it. Okay. Questions on this? Okay.
Negative.
We have what's called single-stage operation. And again, this is an overview. We're going to talk much more about this. But we have single-stage operation. Okay, it's on a one-pipe system. In other words, we have one pipe coming from the tank to the burner. The oil enters through the strainer and goes to a reservoir inside the pump. It has gear teeth in the pump that squeezes the oil and discharges it to the pressure side. Now, it doesn't directly go to the nozzle. It has to build up pressure under a regulating valve that then discharges the oil to the nozzle. I will probably, tomorrow, I think I have a video link that I'm going to give you guys that actually shows you this entire operation. Suntech Pumps and Beckett has put out a really great video that shows how this works that I want you guys to look at. There's also a thing called a two-stage system. It's basically the same operation as the single stage, but the first gear provides vacuum and lubrication. The second gear provides the pressure to the nozzle. And the two-stage system needs two pipes, okay, that actually the excess oil gets sent back to the tank. So we have my burner and my pump right here. We have my tank right here. The two-stage system with a two pipes basically says I'm going to provide oil to the pump, but the excess oil gets sent back to the tank. Now, what's another benefit of a two-stage system? Okay, they basically prime themselves. Okay, so if there's an air bubble in this line, it will eventually, with a little bit of help, which we'll talk about, it will eventually pull enough oil through here that this air bubble will end up back in the tank. A single-stage system, if you have air in that line, you got to bleed that air out of that line. You cannot have any air in a single-stage system. Air and oil burners do not go along very well. Okay. I think that is where I'm going to leave off for today on the pumps. Does anybody have any questions about anything I already covered on this?
No, sir.
Okay, I am going to probably, if it's not with tomorrow's material, I'm going to make it available. There is a video that I'm going to put in big letters, and I'll put it in the announcement sections as well, how to find it. There's a video on oil pumps that I do want you guys to look at. Again, it won't be for today. It will probably be on tomorrow's. But when you see that link, I know a lot of times you don't watch the videos I put out there, but this is one I definitely want you to watch. It's important. Okay, having said that, again, as I said earlier today, for those who are looking for the NORA material, you will always find it near the homework assignments, okay? So, for example, on the 5-6, which is tomorrow, there's NORA chapters there. I think I've already made this homework available. But the NORA chapters we're talking about are right here. Guys, save these chapters. I can't post the whole book. I said this earlier in the course. There's a copyright regulation. Believe it or not, they'll let me post chapter by chapter, but they won't let me post the whole book. Okay, save all the chapters. You have the book. Okay, the NORA book is probably one of your best troubleshooting guides as you go into the field. Okay.
Can we print these out?
What?
Can we print these out?
You can if you want. I don't.
Okay.
It's a PDF file. If you have a printer and if you want to print them, I'm not going to stop you.
All right.
Okay. I just can't provide them in that manner. Okay, or you can go onto the NORA website. If you look it up, there's NORA, I think it's NORA Safe or something like that. You can go onto the NORA website if you wanted to. You can buy it. I think it's like $15. But again, I'm not allowed to provide the whole book to you because of copyright regulations. So, does anybody have any questions for me? Because we are going to wrap this up, because that's where I wanted to be for today. Was starting fuel pumps and the stack relays.
I think so.